Actually?
Yeah, actually. Or hand sanitizer, your call. I gotta use hand sanitizer. Forcing you to be hygienic today. How soon we forget about COVID. Right?
I mean, you got them all up. So, I don't know.
No, Jacob. Where is he?
Yeah.
That was the last one.
Or you just need to.
I feel like today's Friday. I felt like no, I know.
Is everybody here?
What?
Present.
No, Renaya's not.
Renaya is not. Okay. Evie is not either. Okay. So Evie, Renaya, Maggie. I think that's the 3 people. There's going to be a little pause here because people are washing their hands. If you're wondering what the heck is going on, that's what is going on.
I have a group test during class, and I have really good stuff. So I spent so long studying. And I also kind of well, you have 9 chronic enemies. We actually get 100 or more.
Oh God, that had water in it. I know, I'm leaning towards Lee here.
Lee, sit down.
Is there any water in there?
I don't even know what
Soapy water. Yeah, the kind that when you trip on, you fall and hit your head. Seriously. Are you getting it, Hazel?
Yeah.
Thank you.
Wait, what?
Wait, what?
Even drop the thing.
I lost mine.
Are we buying that?
And I felt
Everyone's like, no. Totally not buying it. All right. Today we are going to be working with M&Ms. We are going to talk about a statistical test that is used in science to determine whether or not there is a difference between 2 or more groups. And let me give you an example. Let's say I have 2 AP biology classes, which I don't. And in one of the classes, I give a particular different form of teaching. And that particular class, well, we're going to make that the imaginary class. Okay, that imaginary class that I don't actually teach. The points possible are 50. 50 points possible. And on that test, my ghost class average is 45 out of 50. 45 out of 50. I gave you the standard test. Stop. I'm talking.
Just dump all my carrots out
Lee.
on the floor.
Lee, come on. And the other class, I give my normal test, but I didn't give you the fancy way of studying or reviewing or whatever. And you got 42 out of 50. Would you say that my new strategy worked? Yeah? All right. What if you scored 43 out of 50 and the other class scored 45?
I think
You see what I'm getting at?
they're close enough to know that it might have been one
Yeah,
student
so
did really well.
it's really hard to know for many reasons if there really is a difference or not. And so statistics is an entire branch of mathematics. It's different from mathematics. So my feeling has always been I'm not a real math person, but I did enjoy statistics. And I think that's kind of a general thing. If you like stats, you're not necessarily a math person. If you're a math person, you're not necessarily a stats person. So if you're thinking for my juniors, if you're thinking next year, oh, maybe I'll take AP Stats, or maybe I won't because I hate math. They are different. And one of the things you'll learn about is this chi-square test, if you have not already. And it sounds like you haven't yet. So these tests in general are looking to really verify if there's really a difference between groups or not. Is there really a difference between my ghost class and you all? Or is it just random, or like Carolina says, it's just one person, or what have you? And there's all sorts of tests that you can do. We're going to talk about chi-squared, but we want to do it in a way that's funner. And yes, I am a biology teacher, so I'm going to say funner than maybe other ways that you could look at this. And so we're going to examine. It used to be back in the day, and I don't think this is actually on there anymore, but it used to be that M&M, the Mars Corporation, who makes M&Ms, oh, that's the wrong button. There we go. Had posted on their website the percentages of their M&Ms that were of various colors. So theoretically, you could go into a bag and you could find that 13% of the plain M&Ms were brown, 14 were yellow, 13 were red, etc. Okay, I think it's interesting that the blue's the most frequent one. I don't know. It'd be interesting to know why they wanted to do it that way. But regardless, that's what they say they're supposed to be. Okay, so that in terms of chi-squared, this is a statistical test, is the expected value. We expect that 24% of the M&Ms in a bag of M&Ms to be blue. Okay. What we're going to do today is we are, in a tasty way, going to see if they're full of, brown stuff or not. We're going to see if they're telling the truth or not. Because what we're going to do is we are going to count our M&Ms in this bag, this family, see, we're a family-sized bag, and see if there are 24% blues, 16% greens, etc. Okay, so these are going to be what we call our observed values. Okay, there's going to be an expected. Our expected value is 24%. We're going to see if that plays, if that's actually true or not. Okay, so this is the fun part where I get to actually give you the M&Ms. And I don't know, I might just have to give Lee just carrots because,
No, Richard though, he did just dump on like carrots out on the floor.
I just think that the two of you may not be able to sit next to each other anymore.
He can't come back to
Right, my hands are clean.
You just know Richard. So. Grateful. That's the whole point of the experiment. Whoa, he got a lot. It's not clean over there. I have to eat, man. Bro, I told you you can't come back over here, bro. You go off the bed.
Don't start eating them.
Not yet.
The same too.
That would be fun.
Oh. Yeah.
Okay. I thought you were like I hadn't given you enough there. This is like how I fill out my little box too.
I only have 2 blue ones.
No. I have small hands.
I'm not deficient.
But she only weighs
I'm not deficient. Like aqua.
well, she eats the cat food all the time. Sophie. And she's half deaf.
Sophie!
Dog.
Some people
Terrier.
You said we can't do that.
Oh, yes.
You got a lot of
because you're black.
It's like
Seems like you got a lot of
Ace myself.
You know what I was about to say?
Apologize.
I think that's the Don't move on.
All right.
Don't.
Somebody by somebody you all need to get on your Chromebooks because you're gonna record your values. In classroom, there's a spreadsheet. What I would like you to record your values.
It's how it's supposed to be.
Yes, you're all gonna use this. You know what? How I done it.
Is this how you intended to solve that?
Yes. Solid. The red. And then
More greens. That green was lonely.
I only have one yellow.
Oh.
Don't say that.
No, he is not sharing.
This is how you intended to solve that.
Absolutely not.
Like this? What is that called? Oh, that's a
All right. So if you go into classroom, you should see somewhere. By the way, I posted a bunch of assignments. Some of them are due. One's due tomorrow, but most of them are due later. I just wanted to get it in on your, so that you're getting reminded of it. There we go. People have already put it in. Awesome. You're gonna see what we got here.
So what's this called then?
You have some control. Where?
Oof.
Oh, I see it. It's not an assignment.
Alrighty.
Answer key stuff.
Yeah, you're still loading. Can we eat them now?
Yeah, if you put your numbers in, you can eat them. You can eat them if you put your numbers in. Or if you've counted them.
This will be my square.
You're a weirdo.
What? What?
And we have
your numbers.
We'll go 10 blues.
I got so many blues. I got no.
Oh, did you get it?
You have to use the whole bag because we're plans that.
I feel neglected.
I have 3. Can I eat them?
Boy.
You got 12 oranges?
3. Orange, I have 1, 2. Punjabi, baby. No, it's wavy. So should I change it to wavy later?
Are you sure?
Wait, y'all are already eating. I suppose one will suffice. Just one.
Oh,
If I could only have one.
Christina, that was such a bad
So I can eat it.
But you laughed. I know.
Maybe.
No, because either of
Only
them.
one yellow. Okay. Alright. I should be like, stop it! What the heck? You see this Dr. Look, he just tried to take over.
Kill me now.
We send him back up there. Like, what the heck? I've never seen that before.
Yellow, banana. I think I was like hit out banana once. I'm the one making the joke, so it's okay.
Don't touch my M&Ms, for real. I trust you guys.
I'm not.
I'm not smart. You can have it.
Does everybody have a line to put their stuff on?
Bro, I did not take it. You are such a beast. That's 67.
67 reds.
Bro.
See, already these numbers aren't gonna. Oh, Jacob, 10 reds?
Bro, he got a lot.
Wait, me?
Giles had 10 blues.
What? Oh, damn.
That's more than one.
You said only one. Look, you
Zero.
said only one. Man out over here. Just trying to eat my M&Ms. I actually have.
This is not working. It's got to be 24.
I know, right?
25.
Not anymore. Haha. Off M&Ms.
It's a little greater thing, maybe you know people.
And then you were
Hold on, I'm fixing these values here.
I always cut my nails. I don't need
Oh, what's wrong with that?
it.
Oh, 125.
No.
Alright, I didn't. That's right.
That's a bad habit.
Okay, so bro, we're good.
I mean, extra protein will go for you.
Alright, there we go. Those are the real numbers. 511 M&Ms in a bag. That's a lot of chocolate. It's a lot of chocolate. All right. So what are we going to do with this data? It's an excellent question. If you haven't, and you probably haven't, can you open up your the open up the actual lab from yesterday you're supposed to read over? Modified BAC, chi-squared, blah, blah, blah. Open that up. Okay. Yeah, make a copy. So make it your owns. And then you're going to put in there your class data. Class data on the second page there. There's two values. There's observed and there's expected. What did we just count? Observed. Observed. So you're going to put the observed numbers. That's all going to be the same, hopefully. Yeah. Isn't it what?
20%.
It is in percentage form.
I just.
So, and we don't want it to be in percentage form. So we have to change that. So for, yeah, you can share it with the group. It's fine. We know what the observed number is. As Jack pointed out, the expected is in percentage. How can we find the actual number of M&Ms? Expected M&Ms.
Figure out how many are in a bag and then figure out the percentages of that number.
Right. So Let me just pull this down so I can actually see it easier. Has everyone got their numbers in? No.
No, not yet.
Yes. No.
So class.
No. Okay. Hold on a second. Once we get the total number, we're going to take that value and take it times whatever percentage it is. So, for example, if it is 10%, then we would take our number 51,517 times 0.1, which would give us what? Do it in your head. Move the decimal.
51.7.
Thank you. 51.7 M&Ms would be expected to be that color. See where I'm going? Has everyone got the data entered now?
Wait,
Yeah.
so for class data, we put
Yeah, we're using those percentages.
so,
And I'll do the first one with you. I just want to make sure we got the right total. I'm kind of stalling for time here. So are we done?
no, like, so for observe, we put the total.
Are you for observe? You're going to put the numbers that the ones that are down here.
Oh, I see.
And then if we go back to the lab and go up to the top here. Let's do red first since red is the first one on the spreadsheet. Is it the same one on, is it the first one on here? No, it's not, it's brown. Okay, let's just use brown then, whatever. They're the same. So we expect 13% to be brown, so we're gonna take 517 times 0.13. I don't know what that value is. What is that value? It's more than 51.7.
67.1.
Should be a
67 point. Let's round to the nearest whole number. 61? 67. 67. That's brown.
So that's brown. Wait, what? 517 times 0.13 is brown?
Yes.
Oh, I see. Because
Percentage, 13%. Yep. You do the rest of them.
Cool for this on your own.
So go ahead and do that on your own.
What about you? Here you go for this on your own. Silly, bro. You silly.
You have what percentage? Yeah.
Y'all look out.
Wait, so do we have a null hypothesis? Actually,
We do. I haven't gotten there yet.
Oh my god, that was.
Yeah. What's the red? I'm gonna yellow.
Oh, you're good.
Go on the shirt dog.
The total is 60. Are we rounding?
No, they're
Outside.
Where is it?
So where is this right for the total for the expected? The percentage total or is it a number total?
The total?
Number for the expected.
The total number of M&Ms.
Yeah.
517.
So the total.
It's the same. Yeah.
What the?
Hey, good bread.
You could have just told me.
Yeah.
Do we add the numbers? So it's not really which one to red, so.
I'm gonna hold
So
on.
we
Just
round up.
you got all the percentages now, or all the?
Yeah,
expected?
Nah.
Yeah, it's gonna be off a little bit because of rounding. Yeah.
We round up.
Yeah. Which is fine.
Still say 517.
Yeah, that part doesn't matter.
So our expected round is 67.
Got it.
All right.
120.
So now let's talk a little bit more about the actual equation. Let me just find it here. It's kind of small.
So expected total.
Whoa, that's bigger. But now I can't see it. I'll move it over. Come on. Ooh, okay. There we go. There it is. Okay, this is the way you're going to find the chi-squared value. And this is chi-squared. Okay. So some people, when they get this value, when they calculate all this is much easier than it looks. They want to take the square root of this. Oh, I should have used that for one of the test questions. Anyway, don't take the square root of it. Whatever value you get, that's your answer. That's your chi-squared. There's not like a square root of anything. Okay, there's no square root involved in this. This value means to sum together. So what you're going to do is you're going to sum together each one of the categories because we have brown, we have red, we have blue, we have yellow, we have orange, we have green. I think that's it. We have all those categories. So you're going to calculate this value here for each one of the colors. Okay, so I realize I should be doing this because we got people missing. I should be doing this on the screen. So I'm not even sure if I'm still recording. I thought I was. I don't know where it went though. Oh, there it is. Oh, there it is. Okay. Hey. All right. Let's see if I enlarge it. It'll still work. Okay. So let me erase that because that's now all messed up. All right. Yeah. So for brown, how many M&Ms did I observe? For brown? Oh, I observed. Sorry, my bad. I observed. Oh, now it doesn't want to work. Doesn't it say pen? Oh, there. Now it works. Great. 85. Minus my expected? 67. And then I'm going to square that. And then I'm going to take that and divide that by my expected, which is... Oh, sorry, 67. My bad. 67. Remember, this is just that doesn't mean anything. Okay. That's for brown. And then I'm going to add. So when I said sum, that means to add them all together. What's my next one? Plus blue. Yeah, there's some work involved here. Okay. So you're going to do that for every category, and you're going to add them up. When you add them up, that is your chi-squared value. Okay. OE. So I remember how to do it because it's OE and then E. OE. Observed minus expected over expected.
Wait, where do we put the values?
I'm not sure. I don't think there is a space to. Well, hold on. Let me check. Oh, I got to get out of here. Let me make it smaller. Oh, that's nice. I didn't know you could do that.
For yellow, I got 0.0.
Yeah, you have to calculate it on your own. So you can do it on a separate sheet of paper. Now, calculate your... Here. Calculate it. You can work on the computer, but that's kind of a pain in the butt. Or you can do it on a sheet of paper. Take a picture of it. And insert it into the document. Okay.
For green, I got 4 on my paper.
For orange, I got 1.8.
My notebook's missing.
Red. Are you doing red?
Wait, you're doing red?
I'll do red. Zero.
All right, you can take a picture if that's easier.
We're each gonna do one.
Wait, do you want us to show
It helps the show work because sometimes if you don't, what ends up happening is you have no idea why you messed up. If you do it all in the calculator. Yeah.
If we have a number like 124 or sorry, 82.72, do we round up to 82 or still round down?
Round down. Round to the nearest whole number.
So rounding to the nearest whole number will be rounding up because it's 72. So do we round
Oh, I
down?
thought it was 17.
Wait, can you scroll
Yeah.
back up?
Round to the appropriate nearest whole number.
Can you scroll back up? That's,
Scroll back up.
Are you all right? I'm just trying to talk to you.
But you need that.
or did you erase it?
Did you guys get your?
I erased it, but I can put it back up. Oh wait, no, I didn't. It's right here.
The nearest whole number. Okay.
What's that?
Oh, here's
And we ignore the x squared, right?
okay. I put
Yes.
it on yellow.
The x squared is the chi. Chi-squared value. All right. So as you're doing that, can you listen and can you multitask? Yes or no? I know. Yeah, I hesitate. Just because I've done this a long time. So we have an observed number and we have an expected number. And what chi-squared is doing is it's basically telling us. Let's see, where is that on the document? It's asking the question, and it's going to answer the question for us: is the data a good fit with what we expect the data to be? Do we expect to see a value of 85 browns when it says that there's going to be 67? Okay. And it's like that test example I gave you. Let's say browns were, we expected them to be 67 and we found 69. Is that a good fit? Does that seem like it's a good fit or not? When you do this, you come up with what's called a null hypothesis. And this is a little different from what we traditionally think hypotheses should be, because it's null. What does null mean? Yeah, null and void, right? It means nothing. So what the null hypothesis is saying is that, yeah, there is a good fit. And what the numbers that Mars Company is showing on their website is totally in line with the numbers that we actually saw when we counted up the M&Ms. That's the null hypothesis. So we say that there's no difference. Yeah, Jacob. Round in the nearest whole number. Okay. Now, just looking at the numbers, do you think we have a good fit? For some, right? So one of the downsides of the chi-squared is it doesn't tell you where, if there's not a good fit somewhere, it doesn't tell you where that fitness is bad. So it doesn't say, oh, brown is way off, but yellow's spot on. It just tells you there's something off with the data. Okay? So you don't know for sure. We got that chi-squared value yet?
Wait, should we wait till round until we've added everything together?
That'd be better, yeah.
Our group got two very different answers.
Did you both write them down?
Yeah.
Well, we wrote them down. She did them on the calculator.
Yeah, but they like say because I added them and then I did the mix. Was that
So
Because we got 13 and 20. Wait,
that's easy. Yeah.
I'm talking about like we were figuring out like the value.
You guys get it?
Modi, you did red, right? No, we haven't added together yet.
So like
This one, I think this one
for each of these.
and this one was I'm doing it right now. Wait, guys, let's do this more clearly. Okay, let's
Yes.
Once we have a picture, it's 8.
It's what exactly? This is one number.
These are kind of like the margin area.
I don't know why. I didn't know. Like, no, what's 0 besides 0?
Oh, this is no, a lot of them are different.
Yeah, I mean, it's
Put it orange.
We know what you're
Are we doing? Okay, did anyone do red? I did yellow. And I got red.
It's not right.
Oh, we got 49. Yeah,
I got
God, you guys are gonna force me to do this, aren't you?
Yeah. Okay, 3.5.
Okay, no, yeah, for red,
Yeah, it's like 40.
it's 33. I got 33 for red.
I really do.
Wait, Doc,
Yep.
the shot square people are getting like 40 stuff.
Maybe that's like the nice.
Looks like it.
That is nowhere near what. Did I do red? I got 107.
Yeah, that's not right.
I
That I know for sure.
You said round to the whole number for each of the.
Yeah.
Did you square and divide by the expected?
49.2.
Camila, help me out here.
Orange is 3.5.
Yeah, I got 49.
All right. It's asking a question here. What is our null hypothesis? What is our null hypothesis? I stumped you. What's the null hypothesis? Yeah, so it's saying no difference between
Okay, so
we observed and what we expected in the number of M&Ms. Mars Corporation is saying we should find 67 brown, and we found 85. That's cool. That's okay. That's an acceptable amount difference, different number of M&Ms. Yeah, just.
What do different kinds of what determines?
Well, we're getting there. This is unfortunately one of those processes that takes a while to go through. It gets easier as you go along, but it just takes a while to get there. So let me scroll back down. So do we have some consensus on values?
I got 52.
That's better.
what am I doing?
All right. So let's look at this next part. So once you get a chi-squared value, what does that mean? That's the $1 million question that we want to answer. And it says now you must determine the probability that the difference between the observed and expected is simply due to chance. And there's no reason that those values are different. There's nothing going on at the M&M plant to, maybe which one was the lowest? Brown. Yellow. So maybe the yellow M&M nozzle was clogged and the yellow M&Ms couldn't get out. And so as a result, you got fewer yellow M&Ms. But what we're saying is, no, everything's fine with the machinery. That's just, it's not perfect. We're never going to get exactly 67 M&Ms of brown. We could get 68. We could get 62. We could get 85.
Wait, can you just go back up to the
Okay, so we're trying to figure out how much is by chance and how much is not due to by chance, but due to something that's going on inside of the Mars M&M factory. Okay, and we figure that out by looking at what are called the degrees of freedom. What the heck is that? And I'm not the best person to explain this because, not a stats teacher. Kind of wish I could explain it better, but I can't. But I can tell you what it means or what you are looking at. You're looking at, to calculate your degrees of freedom is very simple. You take the number of categories you have and you subtract 1. So how many different colors do we have? 6. So how many degrees of freedom are we going to have? 5. So it's going to be 6 minus 1 equaling 5 degrees of freedom. Okay. Now we have all the information for us to read a chi-squared table. And the chi-squared table, I think, is down here. I'm hoping. Go back. Yes, it is. Perfect. So we said degrees of freedom. Shoot. Degrees of freedom. And our chi-squared. Wow, we got some lag going on. I'm going to go with 48 approximately because we got some rounding issues. Doing it all in the calculator gives you the advantage of not having to round to the very end, and that's going to give you more precise chi-squared. It's also going to mean that if you type in something wrong, it's going to be harder to, I think it's harder to see for people who really like the calculator than maybe not so much. Okay, so this table is called the chi-squared table, and when you are asked to do a chi-square, you're always given the table. And the table is going to have, over on the left-hand side, it's going to have the degrees of freedom. And it will not usually have this thing here. It will not have this line that says reject the null hypothesis or accept the null hypothesis. So remember, our null hypothesis was that there's no difference between the colors that we observed and the colors that we expect to observe. Okay, there should be the same. If we look over to the right, those values are if there's something messed up at the plant and something's going on to change it. Okay, I can't think of really any time where you're going to look at any of these probabilities that are here. The value you're always going to look at is this one right here, 0.05. This is, you're always going to use 0.05.
Oh no, but I mean, is it always going to be 0.05 or is it always going to be the second to last one?
It's always going to be 0.05. So this is showing you that there is a probability that you would generate this value in this chart about 5% of the time on average. 95% of the time, 100 minus 5, you would get this value because there's something going on to make the observed values different from what we expect them to be. Okay? So we're going to look at degrees of freedom. Which row are we going to look at? We're going to look at 5. This is my degrees of freedom. Looking at 5. Ooh, wow, lag. Okay, we're going to look across. And we're going to find this value, 11.07. So that is the value that if the number is greater than that, we are going to reject our null hypothesis. Is 48 bigger than 11.07? Plenty. So are we going to accept or reject the null hypothesis? You're out of there. Yeah. Okay. Because 48 is greater than 11.07. So we're going to reject. And what that means, or another way to say that, is that there is, I'm going to capitalize this, maybe. There is a difference between observed and expected. And that's really all it's telling you. That's all the chi-square is telling you. There's a difference. We don't know at this point from the chi-square what the difference is, or why the difference exists. So you would have to go into your data and say, okay, well, yellow, we're way off. Brown was pretty far off too. So then you go back to the factory and say, well, let's look at the brown and the yellow manufacturing equipment and see if something's up with them. Yeah.
I'm a little bit confused because you said that there is a difference between the observed and the expected, but couldn't we have determined that just from those initial values we found?
Again, where do you draw the line?
So how come? Well, then are we drawing the line at 0.5?
Yeah. So, I mean, one of the things that statistics does, all sorts of things, is used in all sorts of avenues of the world, is that this is a probability. So if there's a 5%, if there's a 95% chance that this is because of something wrong with the manufacturing equipment, there is a 5% chance that it's just chance. And if I had used the other column, and sometimes researchers will use this other column to really drive home the fact that there is a significant difference between observed and expected. That one, that 0.01, that's saying that it would happen about one time out of 100, about 99% of the time, 99 out of 100, you would see that there's something going on, that it's not just random chance. But the reason I mention that is because we actually saw this. This was a big one or it's often a big one in just politics in general, because they'll do surveys. They'll get people on the phone and say, who do you think you're going to vote for? And they say, and then I don't know if you ever noticed this, but they'll talk about, like, for the Georgia election, for example. They said that, I think that was for the Georgia one, that Warnock was going to beat Walker by 2%. Well, the margin of error was 4%. That means that their values could be off by 4 percentage points. So if he's going to win by 2, but there's 4, it could be that Walker actually is 4 ahead and wins the race. And we've seen this in a lot of political battles because the statistics, you're taking that data from that sample size and you're making an assumption that the rest of the population is going to be on the same page and going to vote the same way. And a lot of elections have been inaccurately predicted because you're dealing with statistics. Right? So it is kind of our best guess. Yes, this is real, or no, it's not. Okay. Yeah, Carolina.
So that first row, the 0.9, 0.5, 0.25, etc., is that always the same in all the charts?
Yes, the numbers are always the same.
All the numbers.
All the numbers are all the same. You could look up any degree of freedom table anywhere, and they're always going to have the same values.
And that's what you said. We always look at the 0.5 and see where our degrees of freedom matches that.
Right.
Oh, okay.
Right. So what your value is will change depending on what degree of freedom is, but the numbers for each degree of freedom are always the same.
So those are just kind of like to have a set point where again use that you
Yeah.
reject or accept.
Yeah. It's kind of a standard to go off of.
Okay.
Like I said, doesn't mean it's necessarily right, but and to be honest, whenever I do this lab, it always comes up this way. The number is always much greater than 11.07. And they don't put that on their website anymore either. So I don't know if they must have some way of calculating how many. It must not be completely random, because I've never, I figure with social media by now, if somebody would have come up with a bag that was almost all brown M&Ms or something and posted it, but I'm sure they have a way of doing it. I just don't know what that way is.
I once had a Kit Kat that was just chocolate. Like there was no inside.
Wow. So
I took a picture of it.
I had a girlfriend once whose job when she was in college it was right out of college, I think. She was in business, which is weird. It's weird because of what she did. Her job was to go around. She was kind of like the, what do they call it? It was for General Mills. General Mills makes cereal. And she would go around to these different manufacturing lines, and she would taste to make sure that they tasted right, they looked right. And so she would taste it, and then she would spit it out, because she would do this all day long. She would go into these plants, and she was quality control. That's what it was, quality control. So you mean, you look at the M&Ms. Some of the M&Ms, there were a few of them that were off, right? Like one of them had a couple of round pieces out, almost like little ants had taken bites out. Did you see that? One of them was like that. But most of the time they're round, and they're completely uniformly colored. And that's because somebody in quality control is saying, hey, this doesn't look right. You need to, and that was actually something that she said they would do, is they would go, she would say this needs to be cleaned out, because there's a whole bunch of sugar accumulating and things are not getting powdered correctly. So who knew? But the reason weird that she was in business is her business degree, and then she ends up being quality control and going on the line and doing that. So I thought that was kind of funny. All right. Other questions for me? Okay. In that case, I want you to answer the questions here. And then you can actually put it up for Classroom. You can submit it. Yes, you're going to get points for it. And this is going to be on your test next Wednesday. Way. Chi-score will be on there. You don't have to remember any formulas anytime. You're always given a formula sheet and a table. Yes. You want me to give you problems like these?
Wait, is it the essay?
You want to practice? Yeah, that's what I meant. Yeah. I can do that. What's that?
That's why she recorded the video.
Multiple guess. Choice.
What is the essay portion going to be about?
There is no essay portion.
Oh.
It's just multiple guess. Oh, sorry, my bad. Sorry, I was getting them confused. It's on the cumulative as well. I don't know. I haven't figured out the essay portion yet. Yeah. Yeah. Because it's enduring. It's something you need to know for the AP test too. Probably. Yeah. Yes, it will be for cumulative. I haven't decided for essay for next Wednesday. Yeah.
Second question. So what is rewarded?
If you're rewarded? Rewarded. If you rejected? So if you're saying that 11.707 is a much smaller number, so you're going to reject your null hypothesis, which was the observed and the expected are the same. Why might the observed be different from what you expected them to be?
Does it mean data-wise or M&M?
M&M company-wise. M&M company-wise.
Prediction, or is it supposed to just
Hypothesize.
Yes. Hypothesize. Yes.
So when there's a 0.5 or 0.05 and 0.95, does it mean that there's a 95% chance that that's the reason why there's this difference is chance and a 5% that it's done willingly?
Yes.
Okay.
Yes. Yes. Good. Yeah. So work on this. The other part of today is going to be, after you complete that, tomorrow we are going to do a lab on gel electrophoresis. In order to do that, why can't you preview it? Oh, there we go. Yes, but it will not be. You won't have a problem with it. When it gets watered down, it's much easier. But this is a particular example of it. I want you to read pages 1 through 8.
No way. By tomorrow?
Yeah.
I actually don't know if I can do that.
And I want you to make a family pedigree.
What is
Oh, it's this little thing.
One of these little guys. Do your best. Do your best. Family pedigree. Really easy. We don't have, because this is biology and it's biological, you're either going to have males or females. You don't have non-binary in here, anything like that. So we have squares and we have circles. And squares are going to represent biological males. Biological males. And these are going to be biological females. Okay? A line between them means that they are married. No line between them means that they're not married. Line coming off of them means that they have had children together. And they are, boy, girl. This guy's non-binary, but unfortunately pedigrees don't do that. So there are our offspring, okay? The first generation, second generation. First, second. Okay. We're going to talk more about this after the first of the year. So I just want you to try it.
Do we have to include the diseases?
Yeah, if you could write down, don't worry about the lines and all that good kind of stuff. Just say, this person has breast cancer.
They'll have to have the disease?
Wait,
When you read through the description, it'll tell you what each person has. Like,
which side do we
Wait,
which
but
side
isn't this for our specific?
is this what?
Is this for our specific? Like our family?
No, you're doing it for this person. Sorry, I should have started with that. So what you're doing is you're starting with Valerie. Which reminds me of a song. Valerie loves me. All right, never mind. Bad song. Valerie has found a lump in her breast. Not sure if it's left or right. And she would like to know whether or not she has, first of all, is it cancerous? And second of all, has it spread to the rest of her body? Okay. Background information in those 8 pages is about her family. It actually says here she's 36. She found a small mass. She's concerned because her mother had a mastectomy. You know what a mastectomy is? It's when breast tissues, breast is removed. If you have them both removed, it's called a double mastectomy. That's not done nearly as much now as it used to be because people are understanding now that women that part of their identification has to do with having those parts, and taking away that tissue can be catastrophic for a lot of women. Yeah. All right. So all these people in Valerie's family have had issues. Okay. I know. And this happens. This example is about, this particular example is about P53. Remember P53? Yep. Tumor suppressor gene. So this is a case where we kind of go into it knowing that she has one bad copy of the P53 gene. But in order for her to get cancer, she needs how many copies? How many bad copies? She needs 2. If it's proto-oncogenes, you only need 1. But for tumor suppressors, you need 2. So what we're going to be doing with the gel electrophoresis tomorrow is we're going to be figuring out whether or not she has 2 damaged P53 genes or just 1. Okay. So we'll talk more about that, but reading over that information will be important and doing that pedigree as well. Okay.
How do we attach this thing to?
I need to put up a link and I can do that right now. All right. Any other questions before I stop this Screencastify?